so you did everything in your head, which is really quick. The main important thing, guys, if we're going to find the zeros, we want to find where the y-coordinate is equal to 0, right? You guys all agree that at each one of these points, the y-coordinate is equal to 0. Yeah. So we want to find the x values where y is equal to 0. And yes, I would recommend writing this down. This is actually some notes. So just like we did in Algebra 1 and Algebra 2, we can just simply apply the zero product property. We have a product. It doesn't matter if there's 2, 3, 4, 5, 6. It doesn't matter. The product of these is equal to 0. That means we can set each one of them equal to 0 to solve. Now, wait, one of them is cubed. So if I want to undo the squaring, I take the square roots. Now again, you think, oh, you introduce a square root, that's plus or minus. Yeah, but it's plus or minus of 0. 0 is not plus or minus, so therefore, you're just going to get 0. Undo the cubing, you take the cube root of both sides. Again, anything of 0. So do you guys see? This is why the multiplicity doesn't really matter as far as the answer, because no matter what power this is, you're just going to take the root of that power, right, of using that index. And it doesn't actually change what's inside the parentheses. Do you guys see that? Like I could have put this to the 12th power. You would take the 12th root on both sides. But you'd still get x minus 4 equals 0. Does that make sense? So the power actually doesn't change the answer. It just changes. The only thing we need to care about is the multiplicity. Does it bounce or does it cross? And then here, this is where we got to be careful, because this negative changes it. So even though we're adding 2, we get negative x equals positive 2, negative 1, x equals negative 2. So let's actually graph this.
Attention faculty, we need your help. We are trying to get all students in the hallway in the class. Unless it's an extreme emergency, please do not release students on hall passes. Please help us to get kids in the classroom. Please hold your students unless there's an extreme emergency that students should be out of the classroom. Thank you for your support.
OK, so we have our 3 zeros. Now, to understand what's happening at each 0, we look at the multiplicity. Here at 4, we see that the graph is bouncing. Now, we don't know if it's bouncing up or if it's bouncing down. So I'm just going to do a little like bouncing to represent it's bouncing there. OK? At x equals negative 1, that's to an odd multiplicity, so I know it's crossing. At x equals negative 2, it's an odd multiplicity, so I know it's crossing. Does everybody see what I did with those? Okay. Now, the only other thing we need to do is use our end behavior to help us identify what the graph should look like. So if we did this like we did last class period, we know that the leading term is going to be a positive, negative. So it's going to be a negative. And it should be raised to the, that's x squared. That would be x cubed times x. So that would be 6th power. So that means my graph falls left, falls right. Because when it's even, it's either both up or both down. Since it's negative, it's both down. It's like negative x squared. Same end behavior. So now, just like what I would do, just like when my daughter wakes up and we're giving her her bottle of milk and stuff, I usually put like a little graph for her, and she just connects it using the end behavior. So all we got to do now is go from here to here and connect to the zeros. So we connect, loop. I need to get from there to there, so it's just going to be a little loop. And you guys can see that it bounces. So therefore, it's not bouncing up, but it's bouncing down. So the graph looks something like that, right? We're just sketching. We're not trying to be exact and perfect. But as far as understanding the behavior of the graph, I can see that it's going to look something like that